Hello class, today we are looking at transformations of functions again. So your essential question is, how do I transform functions? Your learning intention. I'm learning to identify transformation on graphs and to write their equations. So you have four parent graphs. Identify what type of graph they are and then write their equation. Pause the video and see if you can do that. Well, I hope you remember at least part of it. If you're looking at the first graph, it's a graph of what? It's a graph of a line. So this is our linear function. And we're going to use f of x is equal to x. Because 0 is equal to 0, 1 is equal to 1, 2 is equal to 2, negative 1, negative 1, negative 4, negative 4. So all we've done is just say that our input and our output are the same. For the next one, it's the graph of a what? It's a graph of a quadratic. This is a quadratic function. Okay, are these two functions the same? No. If they're not the same, we cannot use the same variable to identify them. If this is f of x, we need to use something different than f. I'm going to use g. G of x is equal to x squared. The squaring is what gives you the quadratic. So for the next one, it's not one that you see very often, but it's something that we use more and more as we get into higher levels of math. It kind of looks like a sideways quadratic. This is what we call the square root function. Okay, so we've used f, we've used g, let's use h. H of x is equal to the square root of x. Or h of x is equal to x to the 1/2 power. So as you notice, this is squared, this is to the 1/2 power, and it just kind of shifts it over to where it lays on its side, and you only see half of it. So for the last one, what in the world is that last one that forms a V? It is the absolute value. The absolute value function. Okay, F, G, H, I don't like I or L, so let's go to K. K evaluated at X, we use the expression the absolute value of X. Okay, so now we've got all the parent graphs. So what would the linear function, if you write the equation that will transform the graph in the following ways. The linear function 2 units down. 2 units down means I'm going to do what? Well, I'm going to subtract 2 at the end. So if I want to do this, this will become your We'll use f of x, that's what we're transforming, is equal to x minus 2. What if we do the absolute value 5 units up? Well, if we subtract, we put it at the end, and we subtract at the end, and we go down. If we want to go up, what are we going to do? If we want to go up, we're going to add at the end. So k, evaluated at x, is going to be equal to the absolute value of x plus 5. Do you see how we do that transformation by adding and subtracting at the end of our equation? Okay, the quadratic function, but we're going to go 4 units to the right. That's something new that we learned last class period. So to go to the right, how do we do where does the adding or subtracting go? This time it goes inside your grouping symbol. So let's see, the quadratic, we use the g of x is equal to, remember it goes in here. To go to the right, remember what I told you happened when when it's inside your grouping symbols? It's opposite of what you think. Usually to go to the right we add. But this time we subtract and we square it. The squaring goes on the outside. So when it's in the grouping symbols, it goes the opposite direction of what you're looking for. So let's look at the square root. We used h for that. This time it's 6 units to the left. Our square root symbol is our grouping symbol. So whatever we do to move left or right, we've got to go underneath our grouping symbol. To the left, we think about subtracting, but we will actually add. Okay, what if we want to do multiple moves? What if we want to take that quadratic function, which is g of x, 5 units down and 3 units left? We're transforming it. Okay, 5 units down means I subtract 5 at the end. 3 units to the left means instead of subtracting, I add 3 inside my grouping symbols. Okay, today we are going to learn how to graph the parent graph in the following situations, or the following transformations. We're going to look at the original graph, and then we're going to see what happens when we do different things to it. So if we're looking at the parent graph, which is x squared, negative 2 squared, negative 2 times negative 2 is positive 4. Negative 1 times negative 1 is 1. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. So our original graph looks like this. Okay, what if I take the opposite of that number and then add 3? What is the opposite of 4? negative 4. Negative 4 plus 3 is negative 1. What is the opposite of 1? Negative 1. Negative 1 plus 3 is negative 2. The opposite of 0, well, 0 doesn't have an opposite. Plus 3 is 3. The opposite of 1 is negative 1. Negative 1 plus 3 is 2. The opposite of negative 4, of positive 4 is negative 4, plus 3 is negative 1. So this one will be negative 2, negative 1. Okay. This one will become negative 1, negative 2. Zero, 3. Okay, 1, 2. Okay, so let's take a minute and let's re-look at the table. So the opposite of 4 is negative 4. Negative 4 plus 3 is negative 1. The opposite of 1 is negative 1. Negative 1 plus 3 is positive 2. The opposite of 0, it doesn't have an opposite. Plus 3 is 3. The opposite of 1 is negative 1. Plus 3 is 2. The opposite of 4 is negative 4. Plus 3 is negative 1. This will make the graph much better. So negative 2, negative 1. And then it is negative 1, 2. 0, 3. 1, 2. And 2, negative 1. So if you're looking at this graph, the negative in front of the x squared flips it over. In other words, it's a reflection over the x-axis. The plus 3 moves it up 3 units. So when you put the negative in front of your variable, it will make that reflection over the x-axis. If you add or subtract at the end of the equation, it moves it up or down. Okay, so now absolute value is a distance from 0. Negative 4 is how many units from 0? 4. Negative 1 is how many units from 0? 1. 0 is right on. 1 is 1 unit, 4 is 4 units. So as I graph this, I remember that it makes that V shape. So I start out at 0, 0, negative 1, 1, and I go to negative 4, 4. That's the first half of my V. Make sure I get everything lined up so it goes right to the corner of those boxes. Same thing on the other side. 1, 1, 4, 4. Once again, it goes right through the corner of those boxes. Now, what happens when I add 3 or multiply by 3? Okay, so the absolute value of negative 4 is 4. 3 times 4 is 12. The absolute value of negative 1 is 1. 1 times 3 is 3. And then 0, 3 times 0 is 0. Okay, absolute value of 1 is 1 times 3 is 3. And once again, you end up with the 12. So if I'm looking at this, I'm still starting at 0, 0. This time it is 1, negative 1, 3, and positive 1, 3. What in the world has happened to my graph? Well, remember, we are stretching it. We are making it go up 3 times as fast. So that actually makes it look like it shrank because it goes up so fast. So this is making the output go up 3 times as fast. So, success criteria. I know I'm successful when I can identify transformations on graphs and write their equations. So we've got 2 new transformations today we're talking about, where we put a negative sign out in front of the variable and it will reflect it over the x-axis. And when we multiply and make it a horizontal stretch. So those are the 2 new ones. We'll look at a horizontal compression next time.